As an engineer, you might be comfortable with a CLI, but for your users, a blinking cursor and a 30-second wait is a failure of a design. In generative AI, latency isn't a bug, it's a constraint of the physics. If you make a user wait for full 500 token response to generate before showing them anything, they will leave. Transparency is the antidote to latency. By showing the agent's thought process in real time, we turn a technical delay into a feature. Today we bridge the gap between your backend logic and the professional grade implementation. To build this, we need to understand the data flow. We aren't making a standard request-response call. Instead, we are opening a persistent stream. The OpenAI API sends us deltas, tiny shards of tokens, as they are generated. Our Python backend uses a generator to capture these shards and immediately yield them to the front end. On the Streamlit side, we need to catch these fragments and render them inside a chat message container, while simultaneously using a status expander to house the agent's internal reasoning. This architecture ensures the UI stays alive and responsive, while the LLM does the heavy lifting. Here is the most critical concept in Streamlit: the execution model. Unlike a traditional Flask or fast API server that stays alive, a Streamlit script is ephemeral. Every time a user types a message or clicks a button, the entire script executes from the first line to the bottom. This means every local variable you defined is destroyed and recreated. If you don't use session state, your chat history vanishes on every message. We treat session state as our application's persistent memory, a key value store that survives the rerun cycle. If you don't master this, you'll be building a script that forgets. To get that fluid typewriter style rendering, we have to move away from the return statement. In a standard function, return handbar the entire payload at once, which blocks your UI and creates that frozen feeling. Instead, we use the Python generator pattern with the yield keyword. Think of a generator as a conveyor belt. As OpenAI sends us a single token delta, we yield it immediately to the UI. The function pauses its execution, waits for the next token, and resumes. This non-blocking flow is the difference between a demo that feels slow and a production tool that feels instant. We begin at the terminal. Let's first create our folder and move inside of it. Let's create a new Python virtual environment and activate it. After that, we're installing Streamlit for the front end, OpenAI for our LLM logic, and Python.env to manage our API key securely. After the dependencies have been installed, we create a new file called .env. Here, we put our OpenAI API key. We also create the app.py file. We start by importing our toolkit. We need the OpenAI client for the brain, Streamlit for the body, and .env to load our secret keys from the .env file. Notice we call load.env immediately. This ensures our environment variables are available before we even initialize the OpenAI client. We then set a custom page title and icon to align with the ByteBuilder aesthetic: dark, clean, and minimal. Do you remember the lifecycle slide? We need to initialize our session state. If the messages key doesn't exist in our state dictionary, we create it as an empty list. This list will act as the source of truth for the entire conversation. Without this check, every time the user interacts with the UI, the script would reset and our agent would lose its memory of the previous turn. Now, we implement the generator pattern we discussed. We define getAIResponse. Notice the streamTrue parameter in the OpenAI call. This is the on switch for the real-time data. We iterate through the response object, extracting the content delta from each chunk. By using the yield keyword, we transform this function into a generator that feeds the UI one token at a time, keeping the main thread responsive. Finally, we wire the input to the output. We use the Streamlit chat input to capture the user's prompt. Once entered, we immediately append it to our state and render it. To bridge the UX gap, we use the Streamlit status. This creates a nested container where we can display agent thoughts or tool execution logs. This is where you would normally put your search queries or database lookups. Once the thinking is done, we stream the final answer into a placeholder using a typewriter effect. When we stream, we don't want to keep adding new lines for every word. Streamlit empty creates a single invisible slot in the UI. Every time a new token arrives, we override that same slot. This is what creates the smooth typing effect instead of chaotic scrolling list of words. You will also notice that we added this one to the stream. This is a subtle UX trick. It signals to the user that the AI is actively working and hasn't just frozen mid-sentence. It mimics the behavior of ChatGPT and Cloud, providing a professional, finished look to your custom app. By using Streamlit status, we create a temporary workspace for the agent's internal works. The status.update call at the end is crucial. It collapses the reasoning steps. This keeps the UI clean, ensuring the user sees the answer clearly while still having the option to click and see the logic if they're curious. We're done writing code. Let's jump back to the terminal and clear our previous output. Let's run Streamlit run app.py. This will spin up a local development server. When you run this command, you'll get two URLs, the local one and the network one. Let's use the local URL for testing this. We open a new Chrome tab and paste our URL. You can see that we have built a simple chat UI. Let's now test it. Here in the build something, let's give it hello. You can see the reasoning steps. It's fetching some context from the vector store, synthesizing reasoning paths. Those are some mock examples of what you can do in the reasoning steps. And we also get the answer, hi there, how can I assist you today? Let's ask it to write some lengthy text so we can see the streaming option. Let's tell it, tell me everything about London. And let's see the magic. You can see how nicely it is streaming the output back to us. This streaming option gave us the feeling of a professional, production-ready system. You have just moved from a backend script to a professional-grade interface. We have covered why latency requires transparency, how to handle Streamlit's unique execution lifecycle, and how to implement the generator pattern for real-time streaming. Remember, an agent is only as good as the user's ability to interact with it. You now have the blueprint to build interfaces that show the how and the why behind every AI response. If you found this implementation-focused guide useful, subscribe to ByteBuilder and let's keep building together.